Hello everyone, welcome to my channel. Today we'll be discussing some other problems from chapter 1 of the Carruthers book. Now, before watching this video, if you have not watched my previous videos of chapter 1 from Carruthers book, then please do watch it. The links are given in the description box. Now, let us start with this question. What are the products formed here? In the first reaction, tertiary butyl lithium is given. What is the role of tertiary butyl lithium? It can either act as a nucleophile or it can act as base. Okay, in this case, since there is free hydrogens are available here, tertiary butyl, methyl and CH3 CH3 is present. First of all, tertiary butyl, delta plus, delta minus. Okay, so this charge is going to abstract, negative charge is going to abstract this proton, and negative charge will be in the carbon atom, and we get CH2, and the negative charge will be here, and lithium plus. And then in the next step, number 1, phenyl CH2 beer is given. So this negative charge is going to attack at this carbon, and since bromine is a good leaving group, it will leave and it will give us CH2 nitrogen methyl double bond and tertiary butyl, and addition of this group CH2 pH. Okay, in the first step. Then in the second step, base is KOH is added in presence of methanol and water. It indicates us that there is basic hydrolysis. Okay, so during basic hydrolysis, whenever you see a double bond N such group, just convert this group into a carbonyl type of group, and since there is a hydrogen, so hydrogen, and rest of the part will remain the same. CH2 pH. Okay, further, since methanol and H2 is also given, so further reaction will occur. That is, we write methanol here. Lone pair of this oxygen atom is going to attack on the carbonyl carbon, and charge will go up, and again it will come back, and then this bond will break and charge will be on the nitrogen atom. It is pH CH2 and negative charge over here and methyl group. Further, water is also given, right? So it is going to abstract a proton from the solution, and thus there will be a hydrogen. So this will be the final product of this reaction. Now let us move on to these questions. So what are the difference between these two carbonyls? The difference is that it is a conjugated carbonyl where there is no conjugation possible here. Okay, and what is this reagent? This is an ylide. Okay, and the name of this ylide is dimethyl sulfoxonium methylide. Okay, this is the name of this ylide. So whenever you see this ylide, then keep in mind that whenever there is a conjugated system, in a conjugated system it will give us a cyclopropane. Okay, it will give us a cyclopropane, and it is non-conjugated system, so on reacting with this ylide it will give us a epoxide, so it will give an epoxide. Okay, cyclopropane means this is, and epoxide means this one. Okay, now let's see the mechanism behind this reaction. See the first mechanism. Okay, first of all, this CH2 minus is going to act as a nucleophile and attack at the carbonyl carbon, then this bond will break and a negative charge will be generated on the oxygen atom. Okay, then in the second step, this O minus is further going to attack here, and this group will leave. This group will leave as DMSO, that is dimethyl sulfoxide. Okay, and we get our product as an oxygen, there will be a carbon, so it is an epoxide. Now let's see the next one. Now in the second case, the CH2 minus is going to attack at this carbon, and since there is conjugation and this bond will go there and negative charge will be in the oxygen atom. Okay, negative charge will be in the oxygen atom. Then further, let's see, pH O minus, double bond is there, pH CH2 S plus Me2 and this double bond O. And the next step, this oxygen will again, this negative charge will again come back, and this pi bond is again going to attack at the carbon atom, and this group will leave. Okay, and we'll get our product as a cyclopropane is going to form. This double bond O, pH, and a cyclopropane will form. Move on to our next question. So what is this? This is a dithion compound, dithion. Okay, dithion, and on treatment with butyl lithium tetrahydrofuran, what it is going to give? There is hydrogen, so butyl is going to abstract this hydrogen, and there will be a generation of negative charge. Then this negative charge is going to attack here, since bromine is a good leaving group, so it will leave and it will give us this one. Further, mercury in presence of H2O, it means hydrolysis is going to occur. Okay, going to occur. So since this is a protecting group, it is a protection group for aldehyde and ketone. Okay, now on hydrolysis, deprotection will occur, and we'll get, instead of this, we are going to get double bond O, and on hydrolysis, so we are getting this product. Okay, now let's see the mechanism how this product is formed from this step. First of all, Hg2 plus is given. So the lone pair on the sulfur atom is going to attack here, and it will give us Hg S, and there will be a positive charge, and it was 2 plus, now it will become 1 plus. Then again the lone pair of the sulfur atom is going to go here, and this bond will break, and this positive charge will be neutralized, and it will give us as double bond, see, and here is Hg plus. Okay, and then the next step, since water is given H2O, so the lone pair on this oxygen atom is going to attack at this carbon, and since there is a positive charge, I forgot to give, it will be a positive charge, and thus it will neutralize this positive charge, so it will give us as Hg plus as single bond, there will be OH2, right, and positive charge, double single bond, double bond. Then this positive charge will be removed, as one hydrogen is going to remove from here. The next step, the lone pair over the sulfur atom is going to attack there in the mercury, and it will give us as mercury. Now there will be no positive charge. Okay, and this bond will be carbon, again carbon, double bond. Okay, and there is OH. Further, this bond will go there, and since there is a positive charge, so this charge is again neutralized, and we are going to get our product as double bond O. So this is the product we are going to get. The next question, now let's see how the products are formed in these reactions. This is an aldehyde, This is trimethyl silicon cyanide. I can write it like this: SiCnH minus. It can be written as like that. Then this cyanide is going to attack here in the carbonyl carbon, and it will become O minus. Okay, this O minus is further going to attack silicon, and we are going to get pH H cyanide and OSiMe3. Then in the next step, LDI is given. What is LDI? It is a non-nucleophilic base. Its structure is lithium diisopropyl amide. Okay, diisopropyl amide. This is N minus, so it is a base. Okay. Next, this negative charge is going to abstract this proton, and a negative charge will develop here. We are going to get cyanide, negative charge, OSiMe3. Further, a ketone is given, pH C double bond O Me. So this negative charge is going to attack the carbonyl carbon, and O minus will be there. Further, this O minus is going to abstract a proton from the solution, and it becomes OH. Okay, I am writing directly: Cn carbon, here OH, pH and Me, and there is OSiMe3. Further, it was added in the reaction. Then this group is going to leave, since cyanide is a good leaving group, so it will leave, and hence the product will be pH double bond O C OH pH and Me. So this will be the final product of this reaction.